Hello everyone, welcome to the unit about how to solve matrices by hand. We're going to learn today about some matrix systems, or systems with matrices. We're also going to learn about matrix elimination. Some of the stuff we do today can be very algebra heavy. It can be a little bit tough to understand because of all the fractions and things like that. That's why I have it written out ahead of time so I don't mess it up either. So, we talked about systems before and how to turn them into augmented matrices. Okay? I like augmented matrices with a line like that in it. So why do I put the line there? Because now I have 2, -1, 1 and 4, 2, -1, 1 and 4, and the answers are 5 and 7. So that's an augmented matrix. You don't have to have the line in there, but I think it makes it easier to see. So for example, for this 3 by 3, 3, -2, 1, 5, again I'm going to put the line there to split them. 1, 3, -1, 0, 1, 3, -1, 0, -1, 0, because it's missing, 4 and 11, -1, 0, 4 and 11. So, it's very easy to take a system and write it as an augmented matrix, but then how do I solve it by hand? Well, I'm going to do some things called elementary row operations. There are 3 things you can do. You can add a multiple of one row to another. So I can say 2 times the first row plus the second row, and then put it where the second row was. I can multiply a row by a non-constant 0. So I can multiply a row by, let's say, 3 or -1/4. I can switch any 2 rows, and we very rarely do this one. So, how do I solve this problem? My goal, when it's all said and done, is to get this left side to look like this. And then with numbers on this side. This is my goal. How can I manipulate this to look like this? Well, this is called the identity matrix, and it's got 1s on the columns and 0s everywhere else. So the first thing I need to do is get a 1 here, and then I'll get these 0s and these 1s, and then I'll get these 0s. So I want it to be 1s on the columns and 0s everywhere else. So, there's lots of ways to do this problem. And as long as you follow the rules, it doesn't matter what order you go in. So my way is not the only way to solve this problem. So what I'm going to do, I need to turn this into a 1. I could multiply everything by 1/4, and that would turn it into a 1. But I could also do this. I'm going to do row 1 plus -3 times row 3. Then I'm going to put that into row 1. Now you're going to say, what do you mean by that and why are you doing it? Well, first of all, notice that the only thing that I'm putting in is row 1. I'm doing this and putting it into row 1, which means the other 2 rows stay the same. So let's put those in first. Okay. So now I'm going to do row 1 plus -3 times row 3. So this plus -3 times this. So it's 4 plus -3. Oh, that's 1, which is what I wanted in that corner. Row 1 plus 3 times this. So -4 plus 3 times -5. That's going to end up being 11, right? Because that'll be 15 minus 4 is 11. Row 1 plus -3 times row 3. So this plus 9 will give me 12, and then this plus -3 times this, that's -30, and that'll make +15, which will make -15. So I've got one thing correct. I've even got a 1 here, just happened to be there. Let's make these 0s. Now this is not too bad. I'm going to multiply this row by -2 and add it to the second row, and then put it where the second row is. So what's being changed here? The second row. So I'm going to leave the other ones be. So I'm going to do -2 times this, plus this, and put it there. So -2 plus 2, 0. -22 plus 1, -21. -2 times -12 is -24, plus 3 is -27. Negative 2 times negative 15 is 30, plus 27 is 57. So I've got the 1 here and a 0 here. Let's make this row a little bit easier to work with. I'm just going to, you see that all of them can be divided by 3, or I'm going to make it negative 3. So I'm going to multiply this one by negative 1/3. This step isn't necessary, it just makes life a little bit easier. So if I multiply 0 by negative 1/3, I get 0. Negative 21 times negative 1/3 will give you 7. Negative 27 times negative 1/3 will give you 9. And negative 57 times negative 1/3 will give you negative 19. And again, a calculator can help you there if you get stuck with the arithmetic. That step, again, wasn't necessary, but it's nice to have something a little bit easier. So I need to get rid of this one. Well, let's just do row 1 minus row 3. Let's put that into row 3. So if I do this minus this and put it there, 1 minus, well, first of all, let's stop. This is row 3, so I'm going to leave row 1 and row 2 alone. Ooh, I'm sorry. No, we're putting something in row 3. Okay? Row 1 minus row 3 into row 3. So 1 minus 1, which is 0, into here. Which is good. That gave me the 0 I wanted. 11 minus negative 15 will give me 16. 12 minus negative 3 will give me 15. And negative 15 minus a negative 5 is negative 15 plus 5, which is negative 10. Okay, here's where it's going to get tricky. I got a 0 here and a 0 here. I need to get a 0 here. I can't use this row because then the 1 would move down here. I've got to use this row because they already have the zeros here. What can I multiply this by that will cancel out 16? Well, I know that it's, what can I multiply 7 by to get 16? Well, I can multiply it by 16 sevenths. Because 16 sevenths times 7 would give me 16. But these two wouldn't cancel out. They would actually be a positive 16 and a positive 16. So I want to make it negative. So now that's going to be a negative 16 and a positive 16 will give me the 0 there I need. So I'm going to do negative 16 sevenths row 2 plus row 3, put it into row 3. This is going to get very ugly with some algebra. So row 1 and row 2 are staying the same. 1, 11, 12, negative 15, 0, 7, 9, negative 19. So now I'm going to do negative 16 sevenths times this, which is 0, plus this, which is still 0, and put it into here, which is this. 7 times negative 16 sevenths. These sevens would cancel and give me negative 16, plus 16, which is 0, right there. Good. So now, I'm going to grab a calculator and I'm going to do this. I need, parentheses, negative 16 sevenths times 9 plus 15. That's really ugly, so let's turn it into a fraction. Negative 39 sevenths. I got to do the same thing here. Negative 16 over 7. Negative 16 over 7 times the negative 19 plus the negative 10 on the bottom. It's really ugly, so let's go math, enter, enter. I'm sorry, math, enter, enter. And I get 234 over 7. Starting to get ugly, but it'll get clean again. I wanted a 1, 0, 0. So the zeros here are good, but now I need 1s on this column. Let's make this into a 1. What can I multiply negative 39 over 7 by to cancel it out and give me 1? Well, I know the way to get rid of the negative is to multiply it by a negative. And what will cancel out 39 over 7? 7 over 39. So I'm going to multiply by negative 7 over 39. I'm going to leave rows 1 and 2 be. If I multiply 0 by anything, it stays 0. If I multiply negative 39 sevenths and negative 7 39ths, I get the 1 that I want. But now I've got to do 2 34 sevenths times negative 7 over 39. Well, the 7s will cancel, so my answer is going to end up being negative whatever 2 34 divided by 39 is. So 2 34. This is weird. 2 34 divided by 39. Look at that, it comes out to be a nice even negative 6. So, I've got this part done, but I need to get rid of the 7. What could I do, what could I multiply by that would cancel out 7? I can multiply this row by 1 7. So I'm going to leave the first row and the last row be because I'm only working with the middle row. So if I multiply everything by 1 7th, it's still 0. 7 times 1 7th is 1. That's going to be 9 sevenths. That's going to be negative 19 sevenths. And I want to stop here for a second and show you something. This right here is called row echelon form. Because I have half of the matrix done. I've got the 1s in the middle and I got the 0s here. I don't have the 0s here. If I wanted to, though, I could stop and solve this problem. Remember, this is x, this is y, this is z. I know z equals negative 6. I know y plus 9 sevenths z equals negative 19 sevenths. I can plug in the negative 6 there and solve for this. I know x, I know y, I know z equals negative 15. I could plug it back in. So you could solve this problem, okay? Again, let me just show you real quick how that would look. I'm not going to stop here, but you could. X plus 11y plus 12z equals negative 15. Y plus 9 sevenths z equals negative 19 sevenths. And then z equals negative 6. Now look at that. I know what z is. I can plug it in here and then find y. And then I can plug it in here and find x. So that's one way to do these problems, put it into row echelon form. But I'm not going to stop there. I'm going to keep going until I have zeros up here as well. Okay, so that makes sense. I need to cancel out this 9 sevenths. So, what can I multiply this bottom row by so that when I added it back up, I have to use the bottom row because if I use the top row, I'll move the 1. What can I multiply this 1 by that would cancel out that negative, or that 9 sevenths? I'm going to multiply by negative 9 sevenths. And I'm going to add it. So I'm going to do negative 9 sevenths to row 3 and add it to row 2 and put it into row 2. So row 2 is the only one I'm changing. So 1, 11, 12, negative 15, 0, 0, 1, negative 6. Negative 9 sevenths times this plus this is still 0. Negative 9 sevenths times this plus this is still 1. Negative 9 sevenths plus 9 sevenths is 0. But now I need my calculator. I need negative 9 sevenths times negative 6 plus negative 19 sevenths. So I need negative 9 sevenths times negative 19 sevenths I messed that up. I need negative 9 sevenths times 6, negative 6, plus negative 19 sevenths. Look at that. And now I got rid of the fraction. Now this is just 5. I'm one step closer to being done. I got a 0 here. Now I just need a 0 here and here. I'm going to use this to get rid of the 11 and this to get rid of the 12. So what could I multiply 1 by to make it cancel out the 11? I'm going to do negative 11, row 2, plus row 1. I'm going to put that into row 1. Since row 2 and 3 aren't changing, row 1 is the only one that's changing, I'm going to leave these be. So now let's do this one. Negative 11 times this, plus this, is 1. Negative 11 plus 11 is 0. Negative 11 times 0 is 0, plus 12 is 12. Negative 11 times 5 is negative 55. Negative 55 plus negative 15 is negative 70. I'm almost done. I'm going to use this row, this 1, to get rid of that 12. So I'm going to say negative 12, row 3, because that'll cancel out, plus row 1, and I'm going to put that into row 1. My last step, thankfully. The only one that's changing is row 1. So, negative 12 times 0 plus 1 is 1. 0 times negative 12 plus 0 is 0. Negative 12 times 1 is negative 12 plus 12 is 0. Negative 6 times negative 12 is positive 72 plus a negative 70 is 2. And I am extremely happy now because I've got what I wanted. 1, 0, 0, 0, 1, 0, 0, 0, 1. 1's in the diagonal, 0's every place else. So what do these numbers mean? They mean that x is 2, y is 5, and z is negative 6. It's okay if this is hard for you at first. This is very hard stuff, but you get better with practice. Think about it like a puzzle. How can I manipulate these things to get what I want?